So let's have a look at each one and see how we do. So the histogram figure 1 summarizes the times in minutes that 200 people spent shopping in the supermarket. Now this information is useful because it tells us that 200 people, which is the frequency, is equivalent to the area of all of these blocks. All of these blocks equals 200. Okay. For those who are unsure, a frequency inside is always the area of the block. So we've got frequency here, F. We've got the height, which is the frequency density, and the width, which is the class width. So FD, class width, and frequency density. So you got it here, and this x-axis is the class width. So it's always base times height to find the area of the block. Now, give a reason to justify the use of a histogram to represent this data. Now, for this one, I state that we can use a histogram if the data is continuous. So that's what it is. So usually, or not usually, always, that there must never be any gaps. Sometimes you're given a question with some gaps. So usually we'd have to find some sort of midpoint between the two values. Here there's no gaps, and you can see it's 11 to 21. So data is continuous all the way across. So it's always in an interval. Okay. Now, given that 40 people spent 11 and 21 minutes, so that's the first block here, shopping in a supermarket, so the first block has an area of 40, so just like I wrote. Estimate the number of people that spent between 18 and 25 minutes shopping in the supermarket. So 18 to 25 minutes is very specific. Here we need to split this block across, so we need to find like this kind of area. And then 25 minutes we need to split this as well to find this kind of area. So from here to here. Now to do this, you'll notice that all these values here, the ones in blue, were not given. So like before we solve anything, we need to actually figure out how we got these values. So first things first, looking at this block one more time, this 40 block, we can calculate literally the height of it. And when you calculate the height, boom, it's game over. So the class width here is 10. Between 11 and 21, the class width is 10. We know the area is 40, so to find the height, 40 divided by 10 gives us 4. Once you calculate the height of 4, you can of course deduce the rest of these by counting the blocks carefully. And notice that this has a height of 6, 7.2, and 8, and so on, and 3, and whatnot. So now that we got the height of 4, this is useful because now we can just take a semi-interval of this. Since we're finding, 18, 25, we can firstly do 18 to 21, and that gives you a width of 3. And because the height is 4, 3 by 4 is 12. So that counts for 12 people. Now, up to 25, we want 21 to 25, right? So counting from 21 to 25, that has a width of 4 and a vertical height of 6 because the height is 6. And 4 times 6 is 24. And that's it. So 12 plus 24 gives us 36 people in that time interval. So the answer would be 36. All right. So that's the main bit done, the hardest bit, I guess. Now the median is very straightforward. To calculate the median, when we have 200 people, we half it and we need therefore find the 100th person in this 200 set of 200. Now I use a very cool method known as the linear interpolation. And the way we do this is that first things first, I can do step by step again. I draw a line across, I label the middle part M and represent this as 100. Now all I do here is I look back at the table, at least, well, the histogram, and I have to calculate where does 100th person lie between what blocks. So you will realize that the area of the first block was 40. The area of the second block using the same method, 5 times 6 is 30. And the area of the third block has a width of 5 and a height 7.2. This will give us 36. So using cumulative frequency, we can say that if we had to add and go, we can say that 100 person lies in the third block because 40 plus 30 is 70. And 70 plus 36 is 106. So we have 70 to 106. That is between here and here. So that's the interval, guys. So that's why I put 70 to 106. And therefore, also for the top half, we know for the minutes, it's going to be between 26 and 31 because that is the interval time between the time. Yeah. Usually this question is probably a lot easier to do step by step, but the problem with these questions is that they take a long time to evaluate as well. So it's always good to have a background on this. Now, here comes the main step. So once you fill this up, we need to actually convert this into an equation now. Now what I did, I just found proportions. I said that the difference between M and 31 is equal to the difference between 100 and 106. So always line them up neatly So it's kind of like an art, and you get this part. And then you just pick another pair. So what I did, I said 26 take away 31 is proportional to 70 take away 106. And then there we go. Now we just solve this. So you equal this, and then you just solve for m, and eventually m becomes 30.2. Voila. Now, almost done, guys. Now, part D is the sum of fx, and now this one gave me the most trouble. So x is defined as the midpoint. So for every single interval, we need to find a midpoint. I would actually say put this in the table is easier, but for the sake of not wasting too much time, I calculate the midpoint each one and said, for example, between 11 and 21, the midpoint is 16. Between 21 and 26, we get 23.5, and so on. And now fx literally just means the frequency, the area of the block times the midpoint, and we do it for each one, and then we sum them up, and we should get the total of 6,390. I know you're thinking, yeah, Yassine's voice sounds so tired. It's actually because it's near the end of the fast, and I'm actually recording this during Ramadan. So yeah, I'm starting to feel the strain. Now, bear with me, guys. We're on the very final bit of the question, and yeah, it goes up to G. So question A continued. So given that the sum of f times x squared equals this value, and I thought, you know what, let me copy out the rest of the vital informations: the sum of fx, the number, and the median. For the data shown in the histogram, calculate the mean and standard deviation. Now, these are just easy. So the mean is the sum of fx, which we have, over n, which is 200, and then you get this result, 31.95. The standard deviation, however, is very similar. So ignore the square root for a second. So if you just simply put the sum of fx squared, which is this result, over n, minus the mean squared, this will give you the variance. Square rooting this will give us the standard deviation, which is 13.1. So yeah, these are self-explanatory, I suppose. Now, next one. So the coefficient of skewness is given by 3 times the difference between the mean and median over standard deviation. Calculate this coefficient of skewness for this data. Very straightforward. Just plug in your mean and median and you get 0.40. Now, the manager of the supermarket decides to model these data with a normal distribution. Now, one thing I'm going to add before I read this, something is normally distributed if the mean equals the median, or if in other words, it has a symmetrical distribution, or if the skewness is 0, because if you subtract two same values, you get 0. However, this is not 0. Now, comment on the manager's decision. Give a justification for your answer. So the answer is not a normal distribution because mean don't equal median. And that's it. I'm beat, guys. Well, I hope you enjoyed this video, and leave a comment below. Let me know what you think. If you like the idea of me putting solutions ahead of time and just explaining it, like, seriously, give me a thumbs up or give me a like. And yeah, feedback is great. Feedback is necessary. So yeah, I'm gonna go break my fast. It's iftar time. So see you guys soon. Ciao.